Okay, so I do record my lessons and I put them on a YouTube playlist and all that stuff's linked on Canvas, so that'll be a resource if you guys are ever absent. So day one here, this says prior knowledge, but I don't want you getting freaked out if you see some stuff here that you've never seen before. Okay, so we're going to do some pretty intense problems, analyzing some graphs of functions. Our main goal here, though, is to make sure that we're really comfortable with interval notation, and then to kind of start reviewing some important stuff with functions. So we're going to focus on this graph on the left for right now. We'll call that f of x. And we're going to do some analysis on this. And the reason I do this on two separate pages is so that as we move down the page, we can kind of keep the graph in front of us. It just kind of helps to keep that aligned. If you look down the page, the different things that we're going to analyze are, we're going to find x values for places where the function's equal to 0, not equal to 0, less than, greater than 0. So we're going to be kind of looking at where this graph is in relation to, well, what? You guys tell me. Where is f of x equal to 0 on a graph? It's a special line that's on the graph. Where is f of x equal to 0 on a graph? Where are the y values always 0? What is that special line on the graph that has y coordinates of 0? The whole length of it. The x-axis. Yeah, we're comparing it to the x-axis. When we talk about f of x being equal to 0 or greater than 0 or less than 0, we're talking about whether the graph is on the x-axis or above the x-axis or below the x-axis. So that's all we're really going to do with these graphs. We're going to use that to help us review some interval notation. So this is where the color coding helps me. I am going to color code the places on this curve where the graph is on the x-axis. And I see that happening in some, actually they're only in points. See 4 points where the graph is on the x-axis. Then I'm going to pick a different color and color in the graph where it's above the x-axis, and a different color for where it's below the x-axis. So it's not above the x-axis until here, this little interval there. So here, you can use whatever colors you want, or none. And it's below the x-axis there, there. All right. So this just gives us some visual cues for where we're going to look on the graph. And when we answer these questions, we're going to be giving x values. All of our answers are going to be in terms of these numbers that are along the x-axis. So for my graph, the color choice that I've made, when they say f of x equals 0, we'd be looking at the green part, the red part, or the purple part. That would be the red part. Okay. So I'm just going to make a little red dot here off to the side. I'm trying not to draw on this because I did that earlier and it bled onto the back and then I wasn't able to read anything on the back. So when it's equal to 0, that's the red. And where is it equal to 0? So what I'm going to do is I'm going to draw some dots on here. This is equal to 0 at -1. We're going to include that. Do you guys remember when we include something on a graph, do we do an open dot or a closed dot? If something is included, we should close that dot. So at 1, and at 2, and at 3, and at 4. And should we draw any bars connecting any of those dots? Are there any long stretches where it's equal to 0 all along there? No, it's just at those 4 points, those 4 singular points. All right. So in interval notation, when we're talking about discrete points, those single points, we list them inside of curly braces. I don't know the technical name for these things. Do you guys know what those are called? Curly braces for now. sideways mustaches. And I'm just going to list them from left to right, -1, 2, 3, and 4. And these are x values. If we wanted to get really fancy, we could stick this up in front. This says x has the values of the set of numbers -1, 2, 3, and 4. This is, it looks like a more curved capital E. It's epsilon. It's the Greek letter epsilon. That's not too bad, right? We're going to skip the next one because the next one's super bad. Let's go to this one. We'll come back. We'll come back to the other one. It's just a little intense for this early in the period. F of x is greater than 0. So when I'm looking at f of x greater than 0, for my color choices, is that the green part, red part, or purple part? Greater than 0. Remember, alligator's eating the bigger thing. Alligator's eating the y, so y is bigger. So we're looking at the purple part. How many intervals do you see? How many separate sections do you see where it's greater than? I see 2. You see 2 also? Yes. The first one starts here at 2 and stretches all the way to 3. So I'm going to draw a bar from 2 to 3. Now, is this interval going to include 2? Is the y value greater than 0 when x is 2? It's equal to 0 here, but it's not greater than, is it? So we're going to put a hollow dot here, open dot. And the same thing at 3, right? This would not include 3 because we're not greater than. We're right at 0 at an x value of 3. From 3 to 4, we're not greater than 0, but then from 4 on, we are. So I'm going to have another interval here that starts at 4 and heads off to the right. And that's going to be, again, an open dot because 4 is not included. So there's our 2 intervals. You see how this is kind of just this, these 2 purple sections, but sort of if you were to like roll over them with a big truck or something, flatten them out. No? If I were to just flatten this, it would end up looking, if I were to just squish that down, it would look like that. All right, let's draw these intervals, or let's write these intervals. We always go from left to right when we're doing that. That's key. Okay. So we're going from left to right. Our first interval starts at 2. So I'm going to write 2, 3. Now these are not discrete values, so I either need a parentheses or a square bracket. What am I going to have around 2? Parentheses or square bracket? Parentheses. Well, open dot corresponds to parentheses, right? Closed dot, square bracket. So 2 to 3. 3 also has an open dot, so we'll go parentheses there also. And then we stitch that together with the other interval with this, kind of looks like an uppercase U. It's the union symbol. Have you all seen that one before? Have you seen the upside down version too? We won't mess around with that too much. The upside down version means the intersection. We won't get into that though. We'll union that with our second interval begins at 4. And where does it, air quotes, end? At infinity. It doesn't really end, but we'll say it ends at infinity. 4 has an open dot, so it's going to get a parenthesis, and infinity always gets parentheses. Can't get to it. The way I remember it is you can't technically get to infinity, so can't really include it. I don't know. That's the rule, though. Somebody decided parenthesis for infinity and for negative infinity. We'll put my little x epsilon in front here to make it look fancy. All right, we feeling all right? Let's keep going. Yes, we're doing awesome. All right, this time, this one says we're less than 0. Is that green, red, or purple? That's green. Well, less than 0 is when we're down below the x-axis. How many separate intervals do you see below the x-axis? You see 2 or 3? You see 3? We can't lump these 2 together. They are separated because we're not including this, right? We're not going to include this because that that point does not have a y-coordinate less than 0. So we're going to have to break here, but we're going to go from here to here, from here to here, and from here to here. So let's do that. So it starts at the arrow showing me negative infinity. So we'll make our arrow going off to the left. And it goes right up to where that x-intercept is, which is at negative 1. And are we including the negative 1? No, because it's not less than or equal to. So that stays an open dot. There's our first interval. Second interval stretches from there to 2. And 2 is not included. And then our last one where it's below stretches from 3 to 4. And neither of those are included. So you're right. Looks like 3 intervals that we need to write out. Make sure you always start on the left and move towards the right as you go. Infinity. -1. See if you can do the rest on your own there. I'm putting my answer up, but please try it on your own before you look up here. How are we feeling? You guys nailing this? Does this look familiar to you? Somewhat. All right. In case anybody's starting to feel a little anxious about this, like, oh, this looks way different from what I've done in the past. They're really the main thing I need you to be able to do today. If you had this graph in front of you, would you be able to turn that into this? If you walk out of here today and you're feeling really comfortable with that piece of it, you're good to go. You're good to go. We're not going to be dealing with graphs nearly this complicated, at least not until chapter 3. We will be dealing with interval notation pretty frequently. So we're going to start off with some kind of crazy looking graphs just to make sure we got this interval notation. We'll dial it back. The graphs aren't going to be nearly these complicated, not in this first chapter. All right, I feel like we've done this already, but what's the difference this time? Yeah, or equal to, greater than or equal to. We already did greater than, which was the purple, but now we also have to do or equal to. So it's the same 2 intervals, from 2 to 3, and from 4 to infinity, but what's different this time? We are including 2 and 3. How do we represent that on the graph? Closed dots. And what's that going to change in our interval notation? We use square brackets for those closed dots. Ooh. There's, I think, the first mistake you've seen me make of thousands. You'll see this semester. I wrote 5 instead of infinity at first. That's what they make this stuff for. In erasers. You're going to see me make mistakes, and I appreciate those who will correct me. If you could do it like in a soft and gentle way, I'd appreciate it. I'll try to do the same for you. All right, this next one's my favorite one on here because there are multiple correct answers for this bottom one here, but there's like one best answer. So I'm going to challenge you to do this bottom one on your own. It's going to look a lot like one of the ones that we did up above because we're still looking at the same regions. And once you get one answer, I challenge you to try and come up with another answer. And then see if you can decide which one you think is better. And I got my eye on the time here. We're about to take a field trip here, not too long. So again, my challenge to you, once you come up with one answer to this, see if you can come up with another answer that would also be correct. I want you to do a little bit of quality control. Tell me which one you think is better. If you're not sure about that second one, feel free to spy on your neighbor's paper. Maybe they got something different. It's kind of weird when we talk about a best answer in mathematics. Mathematics is supposed to be this thing where like there are right answers and there are wrong answers. What are some qualities that we look for in better answers and concise? Concise answers. Agreed. Seems like half of what we learn in high school math is like these weird notations that mathematicians make up because they don't like writing out words and stuff, right? Half of the challenge, and some of the stuff we're going to learn this semester, half of the challenge is just going to be like getting past this like new notation you're going to learn. We'll be like, why do they just? Well, because they're lazy. Mathematicians are lazy, or maybe not lazy, maybe efficient, maybe halfway in between. So yeah, I would say shorter is usually better if it means the same thing. These are the two answers that I came up with. I believe that the second one is the better answer. Do you see why those two are both correct? The key is kind of here. That's a little bit redundant. Did I really need to have two separate intervals for this two things? Is there anything separating them? All of the values from negative infinity to 2 are covered, right? So this doesn't need to be two intervals. It could be one. All right, ask the big important question then. Who wants to ask the big important question? About tests. Well, they both count for full credit on the test. There you go. That's what I was looking for. If this was a 4-point question on the test, I would give this one 3.5. I would give this one 4. We're looking for the best answer. 3.5 is a good score. It's all right. It's like a. I don't know. My math is failing me right now. Halfway between a 75 and 100. That's 88%. That's a B plus answer right there. That's good. Average that in with some perfect score answer. You still got your right. I mean, we'll talk more about this. A correct answer is going to get you almost all the points. Okay, it's going to be kind of wishy-washy. When am I going to do this? When am I not? Somebody asked me first period today if I forget to put the little X and the epsilon in front. Am I going to take off points for that? No. All right. This one was messy. Do you see why I didn't want to do this one with you for the second example that we did? It's basically the same as this, but the opposite. We used open dots, and I filled in a bunch, and you don't need to write that out if you don't want to. We are going to go on our field trip now, so I'm going to pause my video here. But when you come back, I would like you to start working on the second column if you have time. And I would actually suggest that you work from the bottom up. These especially if you're feeling confident. If you're feeling pretty confident right now, if you can do these last two here, and I'll tell you one of them has two correct answers, but one better one. If you do these last two, you're in great shape. So when we come back, I'd like you to get busy on this. I'll put the answers up, and then we should be moving on. So let's pause here for now, though. So I'm going to put solutions up. Please check as you go, but don't copy. Don't copy. Try on your own. Let me know if I can assist you. And then we'll move on to the back side here in about 3 minutes. Okay, our goal here are two separate things. Number one, I want to go over some super important concepts from Algebra 2. And those concepts are how do we find x-intercepts and y-intercepts algebraically for any function. And then we're going to be looking at some specific types of functions. So we're dealing with two relatively simple types of functions. You should be able to look at this and know that the shape is a, what, for this first function? What kind of shape? If I drew that, what shape would it be in? Of our parent functions, this is a line or a linear function. And if you, as soon as you see this x squared in this, what are you thinking? Parabola or quadratic. Now, I'm sure all of you, I really hope that all of you can graph this in your sleep and figure out what the x and y intercepts are. But I need you to be able to, for any function that I give you, know the process for finding an x-intercept or a y-intercept. So we'll start with y-intercepts because it's the simplest one. What do we do to find the y-intercept for any function ever? How do we algebraically find the y-intercept for any function ever? I think you just said it. Set x equal to 0, solve for y. That's it. In fact, f of 0 is the y-intercept, right? That's what you do when I ask you to find f of 0. You plug 0 in for x. If we did this for this function, we'd have y equals negative 2 times x plus 4, but we put 0 in for x, which ends up being 4. And I bet many of you already knew that the y-intercept was 4. In this class, when I asked you for intercepts, I do want an ordered pair with an x and a y value. Please and thank you. So the y-intercept is 0, 4. All right, this is a key concept that's going to come up again and again and again. I want to make sure we got this from Algebra 2. Let's go ahead and do it for our second function here. If I want to find the y-intercept for any function ever, what do? Put 0 in for x. So I would take my function, I have y equals x squared minus 4, I plug in 0, and I get y equals negative 4. So 0, negative 4 for that y-intercept. Any function ever, to find the y-intercept, you plug 0 in for x. All right, if you can remember then it's a short step to finding x-intercepts. What small change do we need to make in order to find x-intercepts? This time we're going to make y equal to 0. So to find an x-intercept for any function ever, you set the y equal to 0 and you solve it. So if I set my y equal to 0 here, I would have 0 equals negative 2x plus 4. And we would do a little bit of algebra. I have some wonderful news for you guys. Can you look up here for a moment? I'm going to release you of a responsibility that we've held you to throughout your high school math career. When you solve an equation like this, I no longer need to see minus 4 on both sides of the equation. You can just skip to what the next step would be. I do not need to see you write divided by negative 2 on both sides of the equation. You can just skip to what the next step would be. So those basic algebra 1 steps where you're doing the same thing on both sides of the equation, you don't have to show those anymore. If you don't want to, you're welcome to if it helps you. But you don't have to do that in this class. This one has an x-intercept of 2. That would be 2, 0. And let's do the same thing over here. All right, now this is where there are going to be some differences for the this first chapter. Those of you who are comfortable taking an equation like this and factoring it, like in a matter of seconds, are going to find things much, much easier. And you should be able to do the same thing if this had a 2x or 2 in front of the x squared and a plus 3x in the middle of it. You need to be able to factor any quadratic that I throw at you, and you need to be able to do it in like 30 seconds or less. Okay? We got to be there at this point. Can you factor this one? This is one of those easy ones. Do you guys remember this special name for when you have two things that are both perfect squares with a minus in between them? That's it. Say it again. Difference of squares. Yeah. This is a difference of squares. You see x squared minus 4, you better be able to write x plus 2x minus 2 like without even thinking about it. That should be muscle memory by now. If it's not, that's something that we want to fix sooner rather than later. Okay? Every time that I've taught this class, I have some people that procrastinate on learning how to factor, and it bogs them down and frustrates them. You're going to have to trust me on this. You don't want to go there. So make sure that as you're working your assignment tonight, it's going to have a bunch of factoring on it. Work through it, and then that summer assignment as well if you haven't completed that. The nice thing about having it in this form, when I set the y equal to 0, then it's really easy to solve this now. X plus 2, x minus 2. When we have an equation with factors equal to 0, we're allowed to split it up and make two separate equations out of it and solve those separately. It's got to be equal to 0, but luckily this one is. All right, that's kind of the key thing from the backside here, but let's go ahead and talk through the rest of it, or at least some of the rest of it quickly. Does anybody have any questions up to here? This is a concept. We're going over this today, but I expect that you have this fully ingrained right now. To find the y-intercepts, what do? Set x to 0. To find the x-intercepts, what do? Set y to 0. Okay. Any function, ever. You probably already knew how to graph these, but if you have x and y intercepts, you could just graph those 2 points. You said it was going to be a line. There we go. Easy peasy. If you were able to recognize the second function as a parabola, you know it's going to be a U shape. Did y'all learn whether it's going to open, like be able to look and visually tell if it's going to open upwards or downwards by the equation? This is going to open which way? Upwards, because it's a positive x squared term. And we've got y-intercept. That was supposed to say -4. I don't know. There's a copy error there. Mistake number 17 of the day. We got a y-intercept, and we've got a couple x-intercepts at -2 and 2. If you've got 3 points, I'd say that's enough to sketch a reliable parabola in there. You guys remember how to find the vertex of a parabola? This one's easy, but do you remember how to find it in general? Ooh, okay. That's something that's going to be on your assignment. It might be worth looking at your notes from last year. Quick Google search will get you there quicker, probably. Vertex is a really simple way. Does anybody remember that it's got A's and B's and C's in it? Well, there's a couple different ways. It's part of the quadratic formula. No, but you're close. Just invert that. It's everything except the square root. Opposite b over 2a. You're thinking of something else, though, that we're going to talk about. Do you remember the D word, the thing under the square root? Discriminant. Yeah. Hey, good. All right. It's all up there. It'll come back. Awesome. All right. You guys decide whether you want to practice with these intervals here or not, depending on how you did on the back side there. I'm going to go ahead and move on to the bottom. Let's just talk domain and range really quickly. It's kind of hard to see that. There we go. Do you all remember which one goes with X and which one goes with Y? Which one goes with X? Domain goes with X. Oh, that was awesome. It was like a chorus. When you look at this graph and you think about the x values that appear on this graph, which ones are they? Which x values appear on this graph? Like, for example, an x value of 0 appears in the graph right there. X value of 1 appears in the graph right there. X value of 3 appears in the graph right there. What other x values appear on this graph? 1, 1's right here. 1.5 is right here. 1.512 is about right there. You got it. What'd you say? All of them. Every x value is on this graph, right? So it'd be all real numbers. And this, for this first chapter, I want you to write any of those types of things in interval notation. That would be negative infinity to infinity. Chapter 2, we'll back off the interval notation, and I'll show you a much shorter way, or slightly shorter way to write that. Spoiler alert, it's this thing. You may have seen that before, but not for right now. Have you not seen that before? The double bar R, it means all real numbers. Don't use it for now. How about the range of this graph? What y values appear on this graph? All of them. Have you all learned about increasing and decreasing? This is back in Algebra 1. I wouldn't be surprised if you forgot it because we don't talk much about it in Algebra 1. If you walk the graph from left to right, if you're going uphill, you're increasing. If you're going downhill, you're decreasing. So if this graph is doing the same thing for the whole graph. It is decreasing. I'd say this graph is decreasing from left to right, and it's decreasing for the entire domain. For increasing and decreasing, we give x values. So it's decreasing for the entire graph from negative infinity to infinity. And it's not increasing anywhere, so we could put the null set or the empty set. It's a 0 with a line through it. That means nothing. What's the domain for a parabola? What's the domain for any quadratic? Actually, any polynomial, period. Everything. And the range, same thing? No, the range is different. Bummer. We're going to do the range and interval notation here. So take a look at this graph and tell me, we want to start from the smallest values to the largest. So what's the lowest this graph goes? -4. And it goes all the way up to infinity. Now, is there a point on the graph with a y coordinate at -4? Yes, we better include it with the square bracket. Infinity is never included. These last couple bother some people. Ignore the arrows when you do these. Look at this graph and tell me on which half of it is it increasing, the left half or the right half? The right half it's increasing. Isn't it increasing over here too? The arrow's going up. Don't look at the arrows. If I walk this from left to right, I'd be going downhill. We start going uphill here at 0, and it continues to go uphill to infinity. With increasing and decreasing, we always use x values. This is going to be in a lesson later on, so if increasing, decreasing is a little murky for you, no worries. Increasing would be negative infinity to 0. All right, that's enough there. You guys did an awesome job today. I'm going to stop the notes. I'm going to pass